Hello everyone, we are starting our lecture 1 on dynamics. So the objective of this lecture is to understand the application of dynamics. So you need to think about what could be the application of dynamics. So dynamics means anywhere you have motion. So if there is motion of any machine part or vibration, those are example of dynamics. And we'll also discuss about what is mechanics. So I think you have already studied about statics, and then you have dynamics. So this means body at rest, this means in motion, and this is what we'll be focusing on in this course. We'll also discuss about Newton's laws of motion. Those laws are going to be very important as we move forward. The first law of motion, second law of motion, very important, because to ME, and then third law of motion, which is every action has got equal and opposite reaction. We'll also carry out calculation using SI and US customer unit. So these are only the units that we'll be using for this course. And also we'll carry out some vector calculations. So regarding the application of dynamics, wherever you have vibration, it relates to dynamics. Mechanical system design are important in designing mechanism, machines, and structure. In automobiles and aerospace engineering, that is an application of dynamics. Even in robotics, which involves complex interaction between various moving parts. Fluid dynamics also part of dynamics. I think you will have a separate course on that as well. In engine, crankshaft, and camshaft, where there's a motion, this is also application of dynamics. So you can think about other possible application of dynamics. What is mechanics? So you have already taken course on statics, so I think you know what mechanics is. So it's basically a study of what happens to a body when a force is applied. So when the force is applied, a body can be under equilibrium, that is first condition, or a body can accelerate. So this is a static condition, and when the body moves with acceleration, that would be non-equilibrium condition, which is mostly related to dynamics. We'll try to explain these things in more detail, but this is just an introduction. So we'll try to understand what statics and dynamic means. So if you try to see the branch of mechanics, this is the broad classification. So mechanics can be classified for deformable bodies and then rigid bodies. And deformable body means if you have a body and if you apply the force to it, there is a deformation of body. That means the length either decreases or increases, or in other words, the cross-section area changes. So in other, we have stress and strain. So this is related with the stress and strain. So we will not be studying this. So we'll assume there is no deformation of body when a body is in motion, right? So that's the assumption which we'll be following. So there is a separate course on this which we'll be studying related to deformation. Another is fluid mechanics, which we'll be studying as well. That relates with incompressible fluid flow as well as compressible fluid flow. So this is a separate course again. The one which we will be focusing on would be on a rigid body, and that relates with the statics and dynamics. And I think you already have covered statics, and this is what we'll be covering next. So this is solid mechanics, and under solid mechanics, we will focus on dynamics. So this is our focus, mechanics, the study of how bodies react to the force acting on them. That's mechanics. It can be divided into statics, the body is in equilibrium, and dynamic means the body is in motion. Again, you can divide this into kinematics, where we are focused on the geometrical aspect of motion like velocity or acceleration or displacement. Kinetic means concerned with the cause of motion, which is force. So here force is taken into consideration. So that's what kinetics means. So this is what our focus of discussion will be moving forward. By this time, I think you already know the laws of mechanics, Newton's laws of motion, first law of motion, the famous second law of motion, which is F equals to ma. This is going to be used extensively in the dynamic course. And third law of motion is every action has got equal and opposite reaction. So we will focus on 2 units system of measurement, but before that we discuss about some fundamental physical quantities or dimensions. 4 fundamental physical quantities are length, mass, time, and force. Force is obtained from second law of motion, which is force is mass multiplied by acceleration. So if you know mass and acceleration, you can find out force. So we use all these quantities, 4 fundamental physical quantity, to develop system of unit. So unit means like mass in kilogram, acceleration in meter per second square, force in Newton, and so on. These are called the units. And usually there are 2 system of unit which we'll be focusing on. One is called International System of Unit or SI unit, and another is US customary unit. So whenever we solve the problem, these are only the 2 system of unit we'll be using. So that is why it's very important to understand these 2 system of unit. So I think this table shows us the differences between SI unit and US customary unit. If you see the length, this is a physical quantity. In SI unit, it is measured in meter, and in US customer unit, it is measured in foot. Regarding the time, both in SI and US customary unit, it is measured in second. Mass in SI unit measured in kilogram, whereas in US customary unit, it is measured in slug. So this is important. This is important. So this is the basic unit. Slug is the basic unit for mass in US customary unit. And for the force in SI unit, it is measured in Newton. And as we discussed before, force is ma. So this is here. Force is a derived. Newton is a derived unit here. It's not a primary unit. It's a derived unit because is derived from other basic unit. So mass is in kg and acceleration in meter per second square. So 1 Newton is 1 kg meter per second square in SI unit. So Newton is considered to be derived unit in SI. Whereas in US customer unit, slog is a derived unit. Here, force is in pound, So force, again here, force is MA. So if this is in pound, and mass, we don't know what the unit is, and acceleration is feet per second square. So mass is pound second square feet. So this unit is called as slog. So slog is a derived unit in US customer unit. So that's the slog. So in SI unit, 1 Newton is, so if you have a body 1 kg mass, 1 kg moving with the acceleration of 1 meter per second square, then we say that force applied is 1 Newton. So force is 1 Newton when you have a mass of 1 kg moving with the acceleration of 1 meter per second square. That's how 1 Newton is defined. And 1 Newton is 1 kg meter per second square. In US customer units, so this is important to understand. So again, we can write F equals to MA. Force is 1 pound when, see, here mass is 1 slug and acceleration is 1 feet per second square. So this is how the force is defined in terms of mass and acceleration. So here in US customary, mass has to be in slug and acceleration has to be in feet per second square. And if you just modify this, 1 slug is 1 pound second square per feet. So you tend to get confused with the pound force and pound mass. So for English engineering system, the unit of force is pound force. So you write pound and then F, which is pound force, and the unit of mass is pound mass. Now, how do you relate this pound force with the pound mass? Again, if you try to use, so pound mass relate to the unit of mass, and then pound force relate with the unit of force. So again, if you use the force equals to MA, so this can be defined as 1 pound force when you have 1 pound mass, so moving with the acceleration of not 1 feet per second square but 32.2, so 32.2 feet per second square. So if you have a mass of 1 pound mass moving with this acceleration, then only you have 1 pound force. So if you try to compare with the previous one, here 1 pound is same as pound force is equivalent. Okay, so that means if you try to relate this with the slog, so the same thing again, force is MA, it is 1 pound force when mass is 1 slug and then acceleration is 1 feet per second square. If you try to compare between these two, so both are pound force, so if you compare between these two, the relationship between slug, again these are both the unit of mass, so you get that 1 slug is 32.2 pound mass. This is a very important relationship because as we try to solve the problem, you get a problem in which you see the unit of mass to be in pound mass. But we need to convert this pound mass to slug and then carry out the calculation. So this relation is going to be very important in converting the pound mass to slug and carry out the calculation based on US customer unit. So this is a very important relation. So uh, now we try to distinguish between pound mass and pound force. If you see just pound, you have to understand that it means pound force. And if you have pound and then mass, then it means it is the unit of mass. But if you just see pound, then it means that it is relates with the unit of force. So after this, whenever you see just pound, it means it is the unit of force. It's not pound mass. Okay, so sometime you may be asked to find out, the weight in pound. Then if you have been asked to find out what is the weight in pound, then weight is mass multiplied by acceleration due to gravity. So if you want to find out this in pound, then mass has to be always in slug, and this acceleration due to gravity in US customer unit is 32.2 feet per second square. Okay, so the mass should be careful, it's not pound mass. Always, if you want to find out the weight in pound, mass has to be always in slug. So this is the basic unit. So you need to convert mass to slug. This is how you do it. There are certain common conversion factor between pound force and Newton. So this is in SI unit. Mass, one slug is 14.59 kilogram, and then length 1 feet is 0.3048 meter. So these are the conversion which we may have to know. Okay. Now we'll try to solve some problem that relates with the unit conversion, and all numerical problems are part of class participation. So whatever the numerical problem we do here, please try to solve this problem with me, and then you may be required to submit this work as a part of your class participation. So it's very important to solve this problem with me and then submit in the Blackboard later on. So I think I would ask you to submit these work maybe after Friday, but please try to solve this problem with me right now. But the submission can be done later on. Okay. So here in this problem, what is given here is suppose mass is 50 kg. So this is given here, 50 kg. So you need to determine the weight in Newton and pound using the weight formula. Okay, that's what you need to find. So weight is, we know weight of any body is mass multiplied by acceleration due to gravity. So Newton means in SI unit. For this to happen, mass has to be in kg, and this has to be, acceleration due to gravity has to be in meter per second square. So mass is already given in kg here, so this is 50, and then acceleration due to gravity in meter per second square is 9.8 meter per second square. So if you multiply these two, so you get this to be 490 Newton. So this is the answer in SI unit. And also again, using the weight formula, you need to find the weight in pound. Again, the formula is the same. Weight is again mass multiplied by acceleration due to gravity. So in order to get weight in pound, remember that mass has to be in slug. And acceleration due to gravity has to be in feet per second square. So we want mass to be in slug, so you can convert this 50 kg, convert this 50 kg, so you need to convert this 50 kg to slug using this relationship. So you have here one slug is 14.59 kg, so this is given, or you can say 14.59 kg is one slug. So how much is this 50 kg? How much is this 50 kg? How much is this 50 kg? 50 kg is how much slug? This is what you need to find it out. So 50 kg is how much slug? So this is, if you do this simple calculation, what you get is 1 by 14. 59 multiplied by 50. So this is the mass in slug, right? So this is what we use to convert it. And then remember, it is the acceleration due to gravity is in feet per second square, so it has to be 32.2 feet per second square, and then multiply all these and you should get the answer in pound. How much? You should get pretty close to maybe 110.3 pound. The key thing here is whenever you're trying to find out the weight of the body in pound, the mass has to be in slug. That's the most important thing here. So you need to convert mass to slug and then carry out the calculation. And also in US customary unit, the acceleration due to gravity value is 32.2. This is the standard value. So you should remember this. You will not be provided. You should know it. Okay, that's this is another question now. So here is very similar to this, very simple problem, but these are going to be very important moving forward because these are the basic thing which we'll be using again and again as we move forward. So here for the car, which is 3,500 pounds, so just pound means this is weight. This is weight of the car. It's not mass. If it was mass, it should be pound mass. But here, pound simply means it is the unit of force or the weight here. We need to determine the mass in slug, the mass in pound mass, the weight in newtons using the weight formula, and then mass in kilogram. So again here start with the basic weight equation. So here weight is given as 3,500 pounds. So this is given. So we know weight is mass multiplied by acceleration due to gravity. So the weight given here is in pound here. So the mass has to be in slug, and this acceleration due to gravity is in feet per second square, which is 32.2 feet per second square. So here the weight is given to be 3,500 and mass in slug, this is what you need to calculate, and then you have acceleration due to gravity is 32.2 and you get mass. If you simplify it, you get this to be close to 108.7 slug. So you should always write the unit at the end. It's very important you write the unit, otherwise it's just a number. So it's very important you write the units. Now we have this mass in slug. So this is A. For B, we have mass in, you need to calculate mass in pound mass. And based on our previous discussion, we know that one slug is 32.2 pound mass. Okay, so use this to convert 108.7 slug to pound mass. Okay, and if you do the conversion, you get 108.7 multiply with 32.2, you get this to be pretty close to how much? You can say pretty close to 3,500 pound mass. So this is what you get. Number C, the weight in Newton. Again, weight in Newton. Again, weight is mass multiplied by acceleration into gravity. So for this to be Newton, mass has to be in kilogram, and then acceleration due to has to be in meter per second square. And we know acceleration due to gravity is 9.8 meter per second square. And so you need to know the mass in kilograms. So convert this slug to kilogram using this relation. So you have slug is 14.59. So you can convert this, whatever the mass you have obtained, in slug. So mass is 108.7 slug. You need to convert this to kilogram using this relationship. And what you get is, so this conversion would give you mass to be pretty close to 1585.7 kg. So using this relationship, this is what you get. This is just the unitary method. So put this value here, mass is given here, acceleration is given here, acceleration due to gravity, and then if you put this here, what you get is 15540.7 Newton. And d part is, we already got this value. D part is the same thing here, the same mass here. So we're able to calculate everything here. Okay. Question number 4. So here for the mass in 200 pound mass, so it's not pound, it's pound mass, find the weight in pound. Okay, so we need to find the weight. Weight is again mass multiplied by acceleration due to gravity. In order to find this weight in pound, the mass has to be in slug, and this has to be in feet per second square. So this is a standard value, which is 9, acceleration due to gravity is 9.8, sorry, 32.2 feet per second square. This is a standard value. Here the mass is given in pound mass, but we want mass in slug, so you should use the relationship that we discussed before, which is 1 slug is 32.2 pound mass. So what would be 200 pound mass in slug? In slug it would be 200 200 divided by 32.2. So 200 divided by 32.2. So this should be in slug. This should be in slug. So this is the mass in slugs. The weight would be, again, coming to the basic equation, mass multiplied by acceleration due to gravity. So mass in slug is 200 divided by 32.2, and then acceleration due to gravity is 32.2. So it's given you 200 pound. So here 200 pound mass is 200 pound. See, you may be thinking, how is it same? Is 200 pound mass same as 200? See, the value of this acceleration due to gravity may change. If you go in moon, the value of z won't be 32.2, it's going to be different. So it's not always the same value. So the pound mass and the weight will not be the same, but in this case it turns out to be the same. Okay, and we may have to know some prefix like what does giga means, mega means. Giga means 10 to the power 9, mega means megapascal, so it's 10 to the power 6, kilo means 10 to the power 3, and then also milli means 10 to the minus 3, micro means 10 to the power minus 6, and nano means 10 to the power minus 9. Okay, so these are the symbols that are used. You may commonly see this type of prefix and symbol to denote this different exponential form. Okay, now we will do a simple problem which is based on vector. I think you have done many problem in statics that relates with decomposition and finding the resultant force. So in this problem you have been asked to find the resultant force and its direction, and also the resultant in the vector form. So this is what, so these are the forces here. F1 is 5 Newton, which is at 30 degrees to the horizontal, and F2 is 10 Newton. So that's what it is given here. So the goal is to calculate the resultant force and its direction. So that's what we need to find out. So in this type of problem, the way to do is break all the forces into components. So this is a two-dimensional problem. So always break into horizontal and vertical component. So 10 Newton force is already in horizontal direction. You don't have to worry about that. But F1 force is at 30 degrees to the horizontal. So try to break into component. If you break into component, so this should be wherever it makes the angle, it is cosine, so it would be 5 cosine 30, and then on the vertical it would be 5 sine 30. So if you see here, so what you can write is, instead of this you could write this as 5 sine 30. See, this direction is important. If this is in this direction, it's going up. If it was in this direction, it would go down. So here, since it is towards the right, so it has to go up. And then, so these are equivalent. So this is equivalent. You have 5 cosine 30, and then also you have this 10 Newton in horizontal direction. Our goal is to use the rectangle law to find the resultant. So try to find out what are the summation of forces in x direction. Summation of forces in x direction. See, when you have forces in the same direction, we can add up. So it would be same direction 10 plus 5 cosine 30. And if you do maths, you should get pretty close to 14.33 Newton. So the force in Newton, and then summation of force in y direction, you have only this 5 sine 30, so you have 5 sine 30, and this should give you 2.5 Newton. So this, you can use the rectangle law and then resultant forces. So you could have like, this is the resultant force here. So resultant force is, if you use the rectangle law, it is summation of fx whole square plus summation of fy whole square root. So which means here it is 14.33 whole square plus 2.5 whole square root, and it gives you 14.55 Newton. So this is the resultant force. Now the direction means what this resultant force makes with the horizontal. So it is same as saying, so this is the resultant force here, how much this is making with the horizontal. So this is 10 theta. So 10 theta is this divided by this. So this is same as this. So this is, so 10 theta is summation of fy divided by summation of fx. So theta is, we are interested in theta, so 10 inverse summation of fy by summation of fx. So we already know what summation of fy is, which is 2.5 divided by 14.33. Now you can use the calculator to find the tan inverse of this one, and which gives you theta to be 9.9 degrees. So this is the direction, and also the, so the resultant in the direct in the vector form. So it is same as saying, you know, vector form is fx I plus fyj. So this is what you need to write in vector form. So we already know summation of fx, summation of fy. So it is same as saying summation of this is same as saying 14.33 I plus summation of fy is 2.5 j. So this is in the vector form. So this is what you, so this type of problems are very common. We should know how to break down the forces into component and find the resultant forces. And these are the simple problem, but that could be very much asked even in the exam. So please try to do it by yourself as well. It would be part of your participation work, and you will be required to submit these in the Blackboard. For now, you can just do it in paper, and I'll let you know where to submit on Friday when we have in-person class. So we are going to have in-person class starting from Friday. Thank you very much.